Welcome everyone for yet another episode of Out of Band. My name is Faith Appeal.
My name is Jennifer Winnekers.
And we are Out of Band. Today, we are joined by two guests to discuss the topic of detection engineering. One of them is my colleague, Chris, who will introduce himself. And the other is well-known, Olaf. Will we start with you, Olaf?
Sure. Thanks for having me in the first place. Nice to meet you guys. So my name is Olaf Hartong. I am a consultant at Falcon Force. So where I do detection engineering, threat hunting, I advise people primarily on the defensive side. And of course, I do purple teaming, but then I'm joined with a way more specialized colleague that can actually attack people.
Cool.
We're happy to have you.
Hi, I'm Chris Kulakowski. I'm a threat hunter and detection engineer at IBM. I'm a colleague of Faith's, like she said, and we're the defenders.
Yay! So happy to have you. Okay, Jennifer, let's kick it off.
So maybe based on the introductions, it's kind of clear what we're going to discuss today. Detection engineering. So maybe it's good to start with the basics, guys. What is detection engineering according to you?
Want to take that, Chris?
Yeah, sure. So to me, it is leveraging our telemetry that is available to identify suspect or malevolent activities. It can also entail the visibility component. So, sometimes we're limited by our telemetry. It can entail increasing the telemetry that you have natively. So that could be deploying additional sensors, bringing in maybe some logging that you don't have available through, your native EDR solutions, whatever it may be, and using all of that telemetry to essentially paint pictures of what threat activity could be happening in your environment, and ultimately to identify, suspicious activities.
And
yeah, I totally agree. Yeah, I think for me to add to that is to try to understand how an attacker works. So try to replicate its behavior and use the telemetry that Chris alluded to make a detection that is as accurate as possible to capture that behavior.
So how did you guys get to detection engineering? Is that something that you guys studied, or what led you to it?
Yeah, for me, I'm way too old for that field to even exist. So I studied tele and data communications, which is basically just network protocols and like phone systems and these kind of things. And during the course of my career, I worked at various companies where they started to build a SOC or they had one, and through incident response, I learned a lot about like how an operating system works, how an enterprise environment works. So you get more of a grasp into what is normal. And then I started to work at companies where also attackers were working. So I was trying to learn as much as I could from those usually guys, but sometimes girls, fortunately, how they think, what they try to do from a like adversarial perspective, and that combined with my incident response engagements, I kind of got into this field where I wanted to learn more and write a detection before it actually happened.
Yeah, and for me, it all started. I've been in this industry, cyber, for 12 years, about starting with just IT administration, and then the corporate security space, and then being in security operations, and then back into incident response, doing forensics, again to where I am today, doing more threat hunting and detection engineering. And the need arose when we started to realize that even today's world-class and leading security solutions are not keeping up with the threats. And so we've taken it into our own hands to see if we have coverage for something that's breaking. There may be a new threat article that comes out from Cisco or FireEye or something. And the first question that everyone has is, are we covered?
Yeah.
Or it could also be, are we impacted? So both of those questions. And the only way to answer those questions are to one, do a tactical hunt in your environment to see if those techniques, procedures have been observed in your environment, but also to do some testing and attack simulations that are in line with that of the threat actors profile that we observed in the threat or in the intelligence report, and see if we to see if our security controls identify that activity. And you either have, yes, we're covered, our native detections work as they should, or the answer is no, we didn't detect any of this. And of course, if the answer is no, then you've got some work to do to try and use all of the telemetry that was involved with the attack simulation to write a custom rule so that you're covered and you're not reliant on the vendor itself.
Yeah. So based on what you're describing right now, it sounds like it has a lot of overlap with threat hunting. You yourself are a detection engineer and a threat hunter. Where do you see the separation between the two roles?
I think there are very close similarities. The separation is I would see that the hunter is more in line with the identification of the true threats, whereas the detection engineering capability is maybe we're just trying to see if we're covered or impacted. So there may not be a time, there may not be as pressing of a nature to see if we're affected, whereas the tactical hunting, we may be under pressure to see if we're impacted. Detection engineering could be more of a project-based approach. Let's just make sure we've got coverage for this. We don't know we've had a compromise. Whereas threat hunting, sometimes, you could be compromised. Now you're just trying to do damage assessment, like how many devices are compromised, then you go from there.
Yeah, and I think they go also hand in hand together. Right? So the goal is slightly different. As Chris also mentioned, is for hunting you just want to find bad and try to find it as efficient as you can. And with the detection engineering bit, you also want to end up with a detection rule that you can implement and automate so that it can repeatedly run and these kind of things. Whereas a hunt, you that's more sort of point in time assessments what you're making. You can still repeat those, but usually the outcome of that requires more human analysis than a automated detection would. So it can happen that a hunt is so well written by the hunter that it can actually be automated. So then it should transfer to the detection engineering team to implement that. So in a way, the approach is similar, but the outcome is different. I think that's from my experience.
Okay, and then the outcome, you mentioned that the most ideal outcome for a detection engineer is to automate a detection rule. Are we talking then for a specific type of tooling, such as, for example, MDR, XDR, or a SIEM solution, or can it be everything basically, or?
Well, I don't think it can be everything. But it requires, of course, logs, and those logs need to go somewhere, and you need to have a mechanism that can execute your query. So, sure, some EDRs have that possibility, like endpoint and detection and response tools, or XDR, whatever they want to call it now. A SIEM or a data analysis platform can be the same, where you can centralize all your logs. So sometimes you do it closer to the source, if possible, because why would you ingest something twice? That's just paying for something that is not always the most efficient. Depends a little bit on the organization, but in essence, it's somewhere where you get logs and can run queries, and you could do it there. Depends a little bit on how the organization is structured, if it's a managed service or not. these kind of variables also come into play there.
So
Yeah.
one thing that I know is that, creation of use cases has been there for a while, right? What I don't understand is, why is it all of a sudden the detection engineering is getting a spotlight? Is that a wrong perception from my end, or is that the case? And if so, why?
I would say that you're spot on. It has definitely piqued interest of every organization recently, and in my opinion, I think it's because we are having a hard time keeping up with the adversary, and the security vendors are just as much, they're on the forefront. They're doing the best they can. We're all doing the best we can, but there's a lot more of them, and they only have to get the attack right one time in order to have a compromise, where we have to stop them every time. And so it's the spotlight has become more evident on detection engineering for that reason. We're seeing a longer delay and in vendors pushing out native detections into their platforms, where it may take 1 month, 2 months, even longer perhaps for some of these families of malware to support detections. Whereas internally we could probably beat them if we feel like a threat is targeting our organization. Like, depending on the business, right? Every organization is different. If we're in oil and gas, we have those problems. If we're in technology or a service provider, we have different unique problems. So those problems likely align with the motives of the threat actor, and the vendors, they're trying to meet everyone's needs. So it's much more challenging for them.
Yeah, I think you're spot on there. Indeed. So I think, as you also said, it has been around for decades. Use case design or use case development, it used to be called. Technically, we're doing similar work. I think the only approach is we do it more threat-based. And I think we also, the whole maturity of the whole industry evolved into a way where we understand better how an attacker works. There's more research capability, so we can also sort of use that knowledge to make better detection. So it's just an evolution and a new fancy name to it, but and the work is slightly different, and it's more focused probably. So instead of generic, it's more tailored to the threats of your organization or the generic threats of most organizations that the vendors don't get to because it's too broad, or there's too much as well.
Yeah, because that would have actually been my follow-up question, like what is the actual difference between the terms use case engineer and then detection engineer? But the way that you, Olaf, see it is that it's basically an evolution of a use case engineer.
Personally, yes. Yeah.
Okay.
I think it's more thinking like the attacker, which comes more into also the defensive space, where it used to be, hey, we get a report like we mentioned before, we read it, we take exactly those indicators and we write a rule for that. And that changed a little bit into more of the behavioral part, and maybe combining it with more mitigative measures and these kind of things to make it more efficient and also a little bit more resilient.
Makes sense.
The term engineering and detection engineering throws me off a little bit. How does it differ from, let's say, software engineering? Why do we have engineering in that?
I think they're, to be honest, I think they're very similar. In a software development lifecycle, you have an iteration of like, we have requirements. Then you go into development, you go into test. If there's QA, maybe QA, and then production, right? And we follow a very similar life cycle with detections as well. We have our requirements. Normally the requirements are a theory, maybe, or a hypothesis. is this something that we detect or not? We go in with our requirements and we start poking around, coming up with a query. We see if we've got the behaviors in our environment. Maybe some tuning goes into that. We develop it further. We like Olaf said, we build in resilience, make sure it's going to be future-proofed. Then we go into test. We simulate the activity. We make sure that our query works as it's expected. We're getting the expected results, and then it's ready for the show. We push it to production, and you know, and then there could be a follow-on process to make sure that the detection doesn't break, and maybe that could be something automated as well, firing the detection off every 6 months or so, just to make sure that there's no logic within that's broken unintentionally. So I think they're very similar.
I agree. Yeah, it's and then with most modern platforms, you can actually write your detections as code, so to say. So you can even implement your infrastructure as code. So you put them in separate files, and you have an automated system to even deploy it, test it, maintain it, so to make sure that what you know as your truth is still the truth in your production environment as well. You can use it to do your test environment, validate everything's working. So the whole this part of the industry is also learning a lot from the software development industry, where they've been doing this for years, right? So they've been all kinds of unit tests and all these kind of things. And that's coming into our field more and more. So that's also where the engineering comes into play more, because you don't only have to be good at a specific query language, you now also have to maybe even be a little bit proficient in the scripting language. You have to be able to test a little bit more on the operating system or on the device or in the cloud, where you're writing your detection yourself as well. So you have to be a little bit more versatile than you might have used to be before.
Yeah. So
sorry, Jennifer. Yeah. Do you two have an inclination of tools that you use, or are you are you experts in all the tools, or do you have inclinations on tools, and not necessarily names of tools, but more of do you focus on endpoints, or do you focus on the network, or do you do detection engineering on both sides?
Olaf, you can go first.
Oh, thanks. For me, I used to be heavily endpoint and network focused, and endpoint is by now easier because there's a lot of EDR products. I definitely have a preference there, but that's primarily due to the visibility that they provide. So there's a couple that are really, really strong in the telemetry that they bring, that allows me to do my job as a detection engineer. If I have to rely on only the vendor, then I don't have anything to do. Doesn't mean it's a bad product per se, but for me and my clients, it's usually not the case. So that's where I was focusing a lot. Network is slightly harder because not every company has the ability to gather those those telemetry sources in terms of network captures and these kind of things. It's also quite costly. And not always the same value for money as endpoint. And I've been focusing on the cloud more and more because it's just a lot of organizations are moving there. There's a lot of attack surface. There's not as much research done as on the on-prem bit. So that's interesting to me. And also, it's scary to a lot of other clients. So that's my primary focus areas.
Okay. Chris, do you have anything to add there?
Yeah, there's I believe there's a Twitter saying that NSM is dead. Network security monitoring is dead. And I think it came as the introduction of EDR came, you know, there was less of a reliance on network-based monitoring because we get that and so much more with EDR. And so naturally, I think that EDR has become like the go-to for a lot of this. But I don't think it should be completely tossed away. I still think there's some great use cases using network-based monitoring that EDR, like, you know, EDR is only as good as where it is. and sometimes there are edges in the organization that for some reason maybe they don't support EDR. It could be some flavor of operating system that's just not supported. Maybe it's not a managed asset, but it's on the network. There could be edge cases, certainly. So that would be where network monitoring would still be important. But I think, and I think there's a rule of thumb that every security professional should be as tool agnostic as possible.
True.
That way they're staying on the leading edge of technology, of course, because we see in this industry that a tool I'm using today, 5 years from now, could be completely obsolete. And if we're as agnostic as possible, we're going to continue staying on the leading edge of that tool set, and we're going to be prepared for whatever may come down the pipe.
Yeah. So something that is kind of related to what we've been discussing right now, actually. What kind of skills do you need to have to work as a detection engineer? And maybe also what kind of background or what kind of interests, for example?
Yeah, I think Olaf hit it earlier when it definitely takes a wide array of skill set for this line of work. It helps to have maybe some basic software development because sometimes you might need to reverse a piece of malware and understanding the API calls within a malware sample is important to know exactly what capability it has. It helps knowing a little scripting from time to time just to do some automation in either testing or in firing attack simulations. It just makes it easier to do a script instead of typing out every single command by hand. It certainly helps to have a forensic background to know artifacts, like on every operating system, so Windows-based artifacts, Linux-based forensic artifacts. That way you know what telemetry may be available for you to leverage in your detections and writing your rules. You know, registry components, network connection components, file read, file write, processes. I mean, all of that is crucial in knowing, and I think having like a basic understanding of operating systems and how they interact, I think that really helps.
Yeah, I couldn't agree more. I think from personality traits, I don't think education is required. It helps, and it depends also again on your personality. As I think I mentioned it before, but I sort of did a very technical network telemetry and protocol analysis study, and then I went to art school. So, and I think I learned more at art school, to be honest. What I still apply than in that previous education that I mentioned, and the primary thing there was I think the one thing that I learned the most is they force you to always take a step back. And what I've seen a lot of people do when they get a problem is they dig themselves deeper and deeper instead of taking a step back, doing a helicopter view. What's actually going on? What am I looking at? What I'm trying to solve? And these kind of things. And we were forced at art school, at least, to always do that because you had to explain it to somebody else as well. And those two kind of things help me a lot, at least in my still current day-to-day job, because I still have to explain what I'm looking for to somebody else so that they can also use that detection or whatever I built. And on top of that, I think just a generic inquisitive mindset. So you want to understand how something works so that you can also do something against it. So it's sort of the hacker mindset, but then your end goal is different. So you don't want to hack stuff or break stuff. You want to fix it and detect or defend against it. So it's a similar mindset, just with a different kind of end goal. I think those two things combined with what Chris was mentioning in terms of background knowledge, you'll also learn that if you start like playing around and start investigating, because I still learn almost every day just by either reading something. Google is your best friend. Even Stack Overflow is amazing sometimes. Don't copy paste everything, but it's all these kind of things combined. Just sort of the appetite or the yearning to learn. That's probably the most important thing generically.
Yeah.
Okay.
Yeah, I agree.
What I hear you say, Chris, Alif, from the hard skills, is that the path to a DE may be a little treacherous for someone who has not really worked in a SOC environment or a forensic environment, or someone who's not really done a lot of OS networking type of work. Will that be a correct assessment? Not more of a no, it's not possible, but more of
It'll
you
be
need
tricky.
a little bit more experience. It's not a role that you would go in fresh out of college. Will that be the case?
I think that it's not a hard requirement.
Mm-hmm.
It helps, certainly helps. The experience helps significantly. But like Olaf said, I think the soft skills might be more critical. There's use cases that aren't overly complex, you know, and there's many out there that have 100% true positive rates. They're great detections, and I think the personality traits that maybe you're just not afraid of a challenge, and you're not going to let something like a challenge you don't know how to solve initially overcome you to say like, I have no idea how to do this, and you quit before you even start. But if you have the mindset of, okay, I have this problem I'm trying to solve, and you have the mindset that you're going to sit there and you're going to stare at it until you solve it, even though it's not overly complex, I think that's the mindset that that helps significantly in this field.
Yeah, and don't don't be afraid to ask that question. If you get stuck, don't quit, ask it, or even first maybe try to figure it out yourself. If you get stuck, ask for help. And the interesting bit is I do quite a lot of training where I try to educate people on the detection engineering side. Some people in the training are quite proficient and they just want to learn how I do it or another approach. There's also people that are very, very junior, so they struggle a bit more. But sometimes their approaches are quite surprising because we are sort of in the industry for quite a while. We've learned it to do it a specific way, and a fresh approach, it can definitely be very, very valuable. And on the flip side, some of the best detection engineers I've worked with and still work with. So my company does red teaming, purple teaming, and blue teaming, so everything a bit. But some of the best detection engineers can also be red teamers because they immediately go into that phase of thinking like an attacker. So they know what an attacker would do.
Yeah.
And from what I see is that they are more prone. So they're used to reading documentation. They're used to digging around, trying to find something. Usually the intent is different, but the approach is still the same. So what I've seen a lot is where some of the more or less experienced detection engineers get stuck and get frustrated and might give up. That's the sweet spot of a red teamer, because that's what they do day to day. So they just hit Google again or try to find some other documentation, and their perseverance is slightly different, and that's an attitude that some people have naturally and some have less. So that's something that I sometimes see.
Yeah. So, given your experience as detection engineers, your vast experience, what are some of the challenges that you've come across in detection engineering field?
For me, it's absolutely, this is the number one thing. It is limitations, technologies, and technological limitations is what that's the number one challenge for me. Such as we may have a use case and we know exactly what to look for, but maybe the telemetry doesn't exist. So there's really nothing other than, you know, forensic artifacts that you can get, you know, from just doing your traditional you know, forensic analysis. They're not available to you because for whatever reason they, you know, they're chopped off and not sent to the cloud for analysis. There could be query language limitations. So some of the query languages that I use, there's certain things that just aren't possible. Like a functionality that I might have in one query language might not be possible in another. There could also be scaling limitations. Some use cases where we're looking for sequences. So like I want to detect when A, B, and C happen within a certain time frame, you run into scaling problems because those type of rules and use cases are extremely performance. They take a huge performance hit on your resources. And then finally, I would say maybe the false positives. That's another challenge that we face, is dealing with false positives and the maintenance of detections that you put out there. Things may change in the environment. So a detection you roll out into production one day, 6 months later, may be causing your SOC a lot of pain. And the maintenance of them, it's like a child, you know, as they grow up, they have different needs.
Love that.
Fair enough. Very visual.
Yeah,
definitely. Yeah. I think you touched most of them already. I think a couple of other ones that I sometimes run into is one of them is like the recipient of your detection. So the analysts. We work for MSSPs and like direct clients. So basically any company. And not always do they have the technical capacity to analyze what kind of alerts they're getting. So they get an alert and it's like, I don't know. And they're very busy, so they can't always deal with, I think, the output of what we're trying to build, which is it's a different kind of challenge, I guess. And another one is sort of close to the telemetry is not in the product, and trying to convince the organization, or at least the IT part of the organization, to enable yet another agent or something like that, where it's very hard to acquire the telemetry that would help you. And storing it on the flip side is another problem, where most of it is technical, but sometimes there's some political discussions going on, trying to convince somebody that actually monitoring might be a good way forward.
Thank you. Jennifer, want to take the next one?
Yeah, so we already touched slightly upon skills. We already slightly touched upon what kind of background would be most helpful in detection engineering. So we also already touched upon the fact that juniors can work in detection engineering field, but they might have some difficulties sometimes. So what would you advise someone who either is completely new in cybersecurity, or someone who has been working in cybersecurity but wants to make the transit into detection engineering?
Olaf, I'll let you take this one first. I keep going first, so
yeah, that's fine. That's okay. I think it depends a little bit on what you know, but coming from that same inquisitive mindset, I would highly encourage somebody to invest even some of your personal time. That's sometimes how it has to be. To learn more about what you're trying to achieve. So if you want to do detection engineering, you might want to build a small lab, start playing, and this can be very small and cheap. It can even be one virtual machine, which you can run. Most people can do that, and start experimenting with some of the smaller techniques. Try to see in the logs, what can I see? How can I detect this? And then at least think about it. Maybe you don't have a SIM or an EDR available to you yet, but at least you can start playing with it. And there are even some free ones, like Elastic puts one out, and there's a couple of other ones. It might not be the thing that you might need, it will end up with in a job, but at least try to do that. Try to find a mentor. So if you have somebody in your job, that's amazing. But otherwise, Twitter is amazing. There's so many nice people there, some not nice people, but you can ignore those. There's so many nice people willing to help. I think the Blue Team Village from DEF CON, they also have a mentorship program where you can just sign up. You have to talk a little bit about yourself, what you want to learn, what kind of person you are. They try to find a match, and somebody hopefully is able to mentor you. These kind of things. I've learned so much from the people that I look up to and still do, that most people are willing to exchange all kinds of stuff. And sometimes it's a bit slow. I'm also not always the quickest to respond to Twitter DMs or whatever, but I try, right? So if you find somebody that's either close to you or remote, it doesn't really matter. But if you have a connection with somebody, that's probably the best way to learn.
Mhm.
Yeah, I completely agree with all of that, especially on the mentor aspect. Finding a great mentor and then really just soaking up as much as you can from that person. Additionally, for someone just starting out, I would say don't jump in too fast. It can be overwhelming.
Yeah.
Maybe challenge yourself just a little at a time. Take on one task and work on that task. Don't take on a task too big. Start small, walk before you run, and progress. I think experience comes over time, and I think people learn better at a slower rate than just throwing everything at them all at once.
Yeah.
Things don't absorb well that way. So I think that taking your time, starting slow, and absorbing the experience, that's probably the best way to go.
Yeah, I totally agree with that last bit. It's indeed, so everybody wants to immediately learn how to hack Twitter or whatever, Facebook, right? It's always what you see, and it's a great ambition, but you don't get there in 10 minutes. So usually that takes years to fully develop that skill. I think what I've learned, what I should have learned way sooner, is also taking notes. So I still am not great at it, but making notes of your thoughts. One of the guys that is a dear friend of mine is he's making notes in a way that it's almost blog style. So he's just writing down his like mental process, which is amazing because it's just for me to review that. It's just glorious, but my brain doesn't work that way. So I'm very chaotic. Maybe you already noticed, and it's. So I have all kinds of snippets, but even putting those down for me makes more sense now. Now I try to force myself to do it because I quite often have something that I know I did before. And if I don't know how I did it anymore, which is quite likely if you're busy with all kinds of different things, you have to reinvent the wheel again. So you're also losing a lot of time. And even by writing it down, it sort of reinforces itself a little bit better in your mind. So.
I think that's a very good point to emphasize also here. Yeah, knowledge management is something that is highly underrated by a lot of people, but it's so important.
And even companies, I've seen very few companies that do this well, and that's also, I'm taking the blame myself for that as well. So
that's a sad story. But in closing, is there anything that you would like to share more on detection engineering with our audience before we close the podcast?
For me, it's in terms of detection engineering, I think that it's of utmost importance to test, to validate, revalidate. We come across so many times where the detection may be perfect, but then like schema changes and it breaks, or vice versa. Maybe the detection was written perfectly at that point in time, but then the threat actor changed their I don't know, the way that they're typing. There's many obfuscation techniques that keep evolving, and they're coming up with new things. So building resilience into detections is absolutely important. Never stop learning. Even the smartest people in this industry are continuing to learn every single day. So I think that that's absolutely important. And then also understanding that technology ages very quickly. So I think that the technologies we're using today they may not be the same thing we're using in 5 years. And so I've seen companies that they throw so much into one solution and they think it's going to be a lifetime solution. And that's not the right mindset to have, because I think that, you know, we are, at the human species, we are innovators, we're creators, we're going to continue making things better and improving upon them. So that means that technology is going to continue to change at an extremely fast rate. And, you know, EDR to XDR, whatever the next DR could be, we got to be ready for it.
Love it.
Thanks.
Yeah, I fully agree with all of those. I think also that we keep on forgetting that we're a very young industry, even though it's like around for maybe 50 years, maybe not even that. I can't do the math right now, but it's, if you compare it to like medicine or whatever, it's been around for hundreds of years, and they're still learning, improving, and these kind of things. So we're so young, we're still trying to sort of get into a very good cadence. And I think to add to what Chris mentioned in terms of the vendors or the vendor landscape is don't just blatantly absorb what they promise you in their marketing or in the documentation. Try to understand the tools that you use. Don't get locked into them for sure, but also make sure that like the out of the box detections that they provide you with, they still work. But also on the flip side, they might have out of the box stuff for what you developed like a year ago, and that might make your detection obsolete. So try to understand your products and leverage them to the utmost extent. I think that's maybe even more important. Where you have an EDR or another tool, try to squeeze as much out as you can before you start bolting on more products and using everything for 20%, which probably ends up being less fruitful than spending a little bit more time on one.
Let's throw in a 20% shameless plug. Olaf, I did attend one of your courses this year. Do you want to tell us a little bit about the course that you have going on?
Yes, for sure. Yeah, so it's a detection engineering training on Windows endpoints, at least in that example, where we utilize Sysmon, we use Defender for Endpoint, and we use the Sentinel environment from Microsoft. And what we try to teach there is also end-to-end understanding where the telemetry comes from. How well does your EDR product, for instance, work? And do you need to augment that if you don't have that visibility and you really want that? And also trying to build a detection that is flexible enough so that if an attacker, like Chris mentioned, tries to fiddle with his like modus operandi, that you can still catch it with a sort of more resilient detection.
Thank you. And Chris, in your journey to detection engineering, are there some trainings that you've come across that you found helpful, or some books that you found helpful?
Well, Olaf's training, of course. I would say a lot of GitHub, to be honest. I have learned a tremendous amount of just some really cool ways to write queries and techniques that I've never thought of before, with just the community's involvement with sharing queries. So I mean, there's stuff out there, Kusto queries all over GitHub. There's Splunk queries out there on all of the Splunk community sites. If you're using Elastic's community has great resources for writing rules, and Carbon Black as well. They've got a great community where people are sharing hunting queries. CrowdStrike has a Reddit, and they have a Cool Query Friday where they share CrowdStrike queries. So I mean, I just think the community has contributed so much to the things that I've learned, and that's what I would suggest is absolutely just just start bookmarking some favorite places out there on the internet, and look and see what other people are starting to develop. If they're writing these, then they had a need for detecting some kind of threat within their specific environment. There's probably a likely chance that you have the same need in your organization as well. So it's really good to look at things that people share. And Twitter is also a good place.
Thank you. Jennifer, I guess we're ready to wrap up, please.
I think so, yeah. So Olaf, Chris, thank you so much for joining us today. I learned a ton at least, and I hope Faith as well. Yes. That being said, to our viewers, I hope you guys enjoyed it. If you have any suggestions for topics or guests that you want to see, please hit us up. That being said, thank you all and see you next time.
Bye-bye.
Bye.